What if I told you that the past isn't really gone? That it's more like a place, a destination you could actually visit? Now, this isn't science fiction. This is a very real possibility that was discovered in a mind-bending physics paper from 1949, written by one of the sharpest thinkers in history. So let's get into it, because this idea is one of the strangest and coolest in all of physics.
So let's just ask the big question right up front. Can you travel back in time? I mean, it feels like the answer should be an obvious no, right? We all experience time as a one-way street. It's an arrow that only ever flies forward. But what if? What if the fundamental laws of the universe, the very fabric of reality, have a secret little detour built in? And there you have it. That quote, that absolute bombshell, wasn't written for a movie script. It comes from Gödel, a legendary logician, in a paper he wrote about Albert Einstein's own theory of general relativity. Get this. Gödel found a solution to Einstein's equations that described a perfectly valid universe where traveling to the past wasn't just possible, it was basically baked into the very structure of the cosmos.
Okay, so how on earth did he figure this out? How do you even begin to find something like that in Einstein's equations? Well, Gödel's whole idea, this entire thought experiment, hinges on one single, powerful change to how we picture the universe. He imagined a universe with a twist.
This is it. This is the whole shebang. You see, we usually think of the universe as expanding, with everything flying away from everything else since the Big Bang. Gödel's idea was different. He asked, what if the universe isn't just expanding? What if the whole thing is spinning? Imagine all the galaxies, all the dust, everything, caught in a slow, massive, cosmic whirlpool. That's the core idea. So let's put these two models side by side. On the left, you've got our standard model, stuff flies outwards, and time marches forward. Simple. But on the right, in Gödel's universe, that universal rotation does something wild. It literally twists the fabric of spacetime. And when you do that, time itself can get twisted into a loop. That spin changes everything. To really see how a spinning universe makes time travel possible, we have to peek under the hood at the math Gödel used. Now, I promise, you do not need to be a math genius to get this. We're just going to shine a spotlight on the one tiny secret ingredient in his recipe that makes all the magic happen. Whoa, okay, I know. That looks like a mess. But don't worry, this equation is just what physicists call the linear element, which is a fancy way of saying it's the rule book for measuring distances in this weird rotating spacetime. And almost all of these terms are pretty standard. The real trick, the bit that changes the game, is hiding right at the very end. Let's just break it down real quick. Most of these dx things are just tiny little steps you can take in a direction, forward, up, or through time. But that last term, that is our guy. Physicists call it our cross term, and it is the secret ingredient. You see how it mixes dx0, which is time, with dx2, which is a direction in space? That's the twist, written in the language of math. And that's exactly what it does. Think of it like stirring cream into your coffee. That term forces a connection, a link between a direction in space and the flow of time. It tells space-time that as you move through space, you also get dragged along in time in a weird way. It's no longer a simple grid, it's a vortex. And Gödel put it there on purpose. So what happens when you have a universe that's spinning like a top, with a mathematical blueprint that literally swirls space and time together? Well, you unlock the possibility of a journey that breaks every rule we thought time had to follow. Physicists have a very cool, very specific name for a time travel path, a closed time-like line. Okay, let's just unpack that. A time-like line is just any path through space-time that you or I could actually take. Easy enough. The word closed means it's a loop, so it's a path you can follow that leads you right back to where you started, but at an earlier moment in time. Wild. So what's the travel itinerary look like? Well, first, you need a ridiculously fast spaceship. The idea is you'd have to fly out in a huge circle, fast enough and far enough so that the universe's natural rotation starts to affect you. As you fly your circle, that cosmic swirl literally drags your future direction around until it points back into your own past. You complete the loop and arrive back at your starting point, only you get there before you ever left. All right, this all sounds absolutely incredible. But here's where the rubber meets the road. Gödel proved that this kind of universe is mathematically consistent with Einstein's theories. But the billion-dollar question is, could we be living in it? Is our universe a Gödel universe? And you have to give Gödel credit. He wasn't just some crackpot. He was a serious scientist. So he proposed a test for his own idea. See, in our universe, we observe that light from faraway galaxies gets stretched out. We call it redshift because those galaxies are flying away from us. Any serious model of the universe has to explain that fact. So, does Gödel's? And the answer is a big, fat nope. Not at all. A universe that is rotating but not expanding just wouldn't produce the redshift that we see with our telescopes. So while Gödel's universe is mathematically beautiful and perfectly logical, it just doesn't match the evidence we see out there in the real world. This chart here really nails it. Our universe expands. Gödel's doesn't. His rotates on a cosmic scale. Ours, as far as we can tell, doesn't. And that's the bottom line. His universe allows for time travel, but we have absolutely no evidence that ours does. So you can probably relax. We don't live in Gödel's crazy rotating universe. So if it's not real, why does any of this matter? Well, this is the real kicker. The point of Gödel's work wasn't to build a time machine. The point was to show that Einstein's theory of general relativity, our best description of gravity in the cosmos, was so powerful and so strange that it allowed for universes where the past wasn't set in stone. It showed that time travel isn't logically impossible according to the known laws of physics. And that leaves us with one last kind of spooky thought. Gödel found this shocking loophole in time just by playing with the math. It was hiding inside Einstein's equations this whole time. So if something as bizarre as a time-traveling universe was lurking in there, discovered over 70 years ago, it really makes you wonder, right? What other unbelievable cosmic secrets are still hiding in the math, just waiting for someone to find them?